All right, good. Awesome. Okay, let's take a look at the big triangle. Okay, I'm going to highlight the big triangle. Within the big right triangle, there are other triangles in it, but we're not going to look at the other two. There are two ways to do this problem. One is completely take it apart and redraw it as three triangles. That can be done. So if you don't like the way I'm going to teach today, take the two triangles, take all three triangles, take them apart and redraw them. But there's a faster way. If I don't confuse you, okay? Let's see if I can not confuse you. Okay, CD is called the altitude because it's the height. So CD, this is my altitude. That's my altitude, okay? CD is my altitude. It's the altitude because that's the height of the triangle, okay? AB is the hypotenuse. So AB is the hypotenuse. Okay? So far, so good. You guys with me? Now, if I turn the triangle this way, you can definitely see, right? There's the hypotenuse, right? Ignore the middle, but that'd be the hypotenuse. Here's my right angle, hypotenuse, right? Thumbs up. But it's just upside down, so there's my hypotenuse, okay? Now, this is a leg, and this is a leg. So let's just call it, they're two different legs. I got a leg here, and I got a leg here. Okay, again, I'll turn it upside down. You know, it's got to be legs of a right triangle are the parts that make up the 90, okay? All right, so those are my legs. But they're two different legs. So just to make it easier, I'll call this the first leg and the second leg. You okay with that? Leg one, leg two? Okay. So I know that AC is leg one, and CB is leg 2, all right? Now, the hypotenuse, all the way across, it got cut up actually into two parts, didn't it? So, I mean, AD is part of the hypotenuse, and DB is the other part of the hypotenuse, okay? So, I'm going to call this my hypotenuse part 1, and let this be my hypotenuse part 2, okay? So it's not the entire hypotenuse, it's just pieces of it because they're connected right here. So I'm going to say that AD then is going to be my hypotenuse 1, hypotenuse part 1, and DB is going to be my hypotenuse part 2, okay? Now, are you ready? I'm going to say it, I'm going to show it, you're going to get it, okay? Here it is. If you were to take the triangles apart and put the pieces together, like we did on the front page, this is a part of this triangle, and it's a part of this triangle, right? You guys agree? So the formula goes like this, watch. It's going to be altitude times altitude is equal to hypotenuse 1 times hypotenuse 2. I'll say it again. This times this is equal to this times this. All right. This times this, or this square, is equal to this times this. I'm going to write it, okay? Okay, I'm going to write it, okay? So we're going to say altitude squared. We're going to say our altitude squared is equal to our hypotenuse part 1 times hypotenuse part 2. Okay, I'm going to say it again. Okay, so you guys get it. I'm going to say this times this, or this squared is equal to this piece times this piece. Okay, that's the formula we're going to use. And it really comes from just taking the triangles apart, and it would really actually work. But it's so much easier just to have a formula that we just use, okay? So this times this is equal to this piece times this piece. Okay, thumbs up. Does that make sense? Okay, good. Now, let's go to the second triangle. Okay, now the leg theorem is a little bit different, okay? So again, this is going to be my leg 1. That's my leg 2. That's going to be my hypotenuse part 1 and my hypotenuse part 2 and my entire hypotenuse. Okay? You don't need the altitude for this theorem. So I'm looking at the entire blue triangle. And you ready? It's going to be, you watching? This times this equals this times all of this. I'll show it again. This times this is equal to this times all of this. Or, I'm going to write this down because it seems confusing, doesn't it? Or, this times this is equal to this piece times okay? So, if I want this leg, then this is the piece of the hypotenuse that's attached to it, right? So it would be this times this is equal to the piece that's attached to it times the entire hypotenuse. If I'm using this leg, and this is the piece that's attached to it, right? Leg times leg, hypotenuse, piece, times the entire hypotenuse, okay? Let's write that down.
What does this
So what we're going to see application of. So it's similar triangles. So what it gives us, let me flip it back over, is it's a shortcut to writing all 3 of these triangles down and then finding out what goes together, okay? It's actually quicker. It's a lot quicker because you can see how long it took me to redraw these and how many different combinations there are. You agree with that?
Yeah.
Right? So it's a shortcut.
So does it just give you the ratio?
Yeah, it does. So I'm going to go, there's 2 parts, okay? First, if we're working with leg 1, or if we're working with leg 2, okay? It's really the same formula. It's the exact same formula, but it just depends on what leg you're working with, okay? So it's going to be leg piece 1 squared is equal to the hypotenuse that it's attached to, okay? It's equal to the hypotenuse 1 times the entire hypotenuse, okay? And we're going to use these when I pass out the second piece of these notes. I'm going to use these formulas to help us, okay? So then if I want this leg, it's going to be my leg 2 squared is equal to the hypotenuse piece that's attached to it times the entire hypotenuse. Okay, now let's pass out the second piece of these notes so you can see how it's used, because right now it's kind of confusing, isn't it? I'm sure you're confused, okay? All right, so let's take a look at the second part of this, okay? Now we're not going to do all of these on here, but I want to do some of these, okay? This is, are you confused? You should be, but let's see if I can make sense out of it, okay? Can you wait? I don't mind, yes, but people wait. Now, let's see if we can make any sense out of any of this, okay? Right? No, I like the colors. I like the colors, Maddie. Scott likes pink, doesn't he? Okay, so let's go to number 3. Let's start right with number 3, okay? Let's go right to number 3, okay? So I need to find the value of x, right? And what I have to do is, I know in the value of x, I've got the altitude, right? I've got the altitude, okay? So, that's not going to, right? So, in order to find the altitude, what I'm going to do first is I'm going to find either part of the hypotenuse or the other part, right? So let's find this piece right here. I'm going to call this y for right now, okay? Let's just call this y. And that, I don't know why, because the whole thing's 10, but this is part of it and that's part of it, okay? If I find the value of y, I can get this piece here, okay? So here's how I'm going to approach this. I've got legs and part of my hypotenuse. Let's see if I can slide this in, okay? So I'm going to go leg squared. Leg squared. I'm going to go 8 squared is equal to the hypotenuse part that's attached to, which is y, times the entire hypotenuse, which is 10. Okay, I'm just using this, just use this formula right here. Okay, I want the leg squared, 8 squared, is equal to the hypotenuse piece that's attached to times the entire hypotenuse. Now I can solve for y, right? I'll let you look at this. It's confusing. So then I get a 64 equals a 10y. If I divide by 10, I get 6.4. Okay, now, if this is 6.4, right, then the other piece, the whole thing's 10, right? What's 10 minus 6.4? What's that, 3.6? So this is 3.6. All right, now let's see if we can find the altitude. So the altitude is this formula. Okay? So I'm going to go, okay, altitude squared. I'm going to go x squared equals, let's see, the hypotenuse piece 1, which is my 3.6, times my other piece, which is y, which is my 6.4, right? All right, so I'm going to need a calculator, which I'm going to grab quickly. This is hard, isn't it? I'll work with you on this, okay? I'll even work with you on your homework, don't mind. It's usually a day that I have to help quite a bit, okay? So then I'm going to go, okay, what's 3.6 times 6.4? I get an answer of 23.04. X squared equals 23.04, and then I'm going to square root it, and the answer would be about a 4.8 is the altitude, okay? All right, let's do number 5 together, okay? Let's do number 5 together. I want to keep working with you, okay? Are you confused? Okay, let me go through. Let's keep doing another one, okay? Let's do 5. 5 is nearly the same kind of problem, okay? All right. So with 5, to do the altitude formula, here, let me show you why I can't do the altitude formula yet. Okay, the problem with the altitude formula is this. I know the whole, I know this is 17, you with me? But I don't know
Please excuse this interruption. Chloe Killian, please come to the office. Chloe Killian to the office.
Okay, one more time. So this formula says altitude squared, that's this, is equal to height piece 1 times height piece 2, right? But I don't know these two pieces. I know the whole thing's 17, so okay, I'm going to go, okay, well I know the legs, so I'm going to back myself up and use the leg formula, okay? So I'm going to use the leg formula. So I'm going to go back.
You use either one or two, it doesn't matter.
It doesn't matter. So Scott, which leg do you want to use, 15 or 8?
Let's use 8.
8 it is, okay? And then if that's the 8, then let's make this the, let's call this the y, which is the piece attached, right? So it is, you ready? It's leg squared. So the formula is leg squared equals the part attached times the entire hypotenuse, okay? Leg squared, so it's 8 squared equals y times 17 or 17y. All right, now I'm going to need to use my calculator. That's going to be a 64 equals 17y. 64 divided by 17, I get an answer of, oh gosh, not a very nice answer, 3.76. Okay, so if that's the case, then this piece is 3.76.
Which makes the other one
17 minus that, right? About 13.24, okay? Now I've got a formula with the altitude. So my altitude formula says altitude squared is equal to this piece times this piece, okay? So I'm going to take my altitude squared, which is my x squared, equals my piece, my 3.76 times my other piece, so 13.24. All right, so I'm going to go 3.76 times 13.24, about a 49.9, and I'm going to take the square root of that. X squared is about a 49.89, and I'm going to take the square root of that answer, and I get about 7.06, or about 7. Okay, now let me keep working on this, okay? This is confusing. I know it is. That's why I always help this day with homework, okay?
Does it matter, like on this last one, does it matter which one you label as leg 1 and leg 2?
No, you could have gotten the exact same answer if you've done the whole thing with the 15.
And you could have said like the 15 is leg 1 and 8 is leg 2, it doesn't matter.
Right, right. Yeah, Tessa? Tava, sorry, my bad. Yeah.
So does it usually go like use the leg theorem first and then the altitude, or does it matter? Like, do you
S-
look at what you, like the information that you have and then you use the one that helps you get the other one?
In this case, yeah, I would. Now, when we turn the page, you're going to see that maybe you do it differently, okay? But before I do anything, geometric mean just says this. Geometric mean is, it's going to be x over a equals a over y. In this case, it's just going to be, so geometric mean is just 3 over x equals x over 12. That's the geometric mean, which really is to multiply these, or the shortcut is this times this, and take the square root of it, okay? So I don't want to confuse you, but it's going to be this times this. To do a geometric mean, you're just going to go 3 times 12 equals x squared. 36 equals x squared. You take the square root of it. Okay, that's all you do, which is 6. I'll do it again. I'm sorry I'm confusing you. I don't want to confuse you, okay?
What's this for?
Well, I don't even care if you know the geometric mean, but it's in your homework. So you're just going to multiply these. 10 times 24. And the square root of that is a geometric mean. Okay, that's all you do. Multiply them, square root of it. That's all you do.
Wait, what was all that jazz over there?
Yeah, that's what the book wants you to know, but, you know,
Don't we just
multiply them and square root. That's all you need for geometric mean. That's it. Okay, now let's look at the back, okay? Now the back's a little bit different, okay? Okay, so, number 9. You got to find x. Okay? I wouldn't use, on number 9, I wouldn't use any of the stuff I just taught you.
Oh, wait, because we could do the next
There you go. Yeah, don't even, like, on number 9, don't even do it. Just Pythagoras theorem. You guys agree? Just plain old 32 squared plus 24 squared equals x squared, right? So I would go straight to clear. I'm going to go my 32 squared plus my 24 squared. I get 1600 equals x squared. Square root. Root of 1600 should be 40. Yep. Okay. I'm going to do 10 and 11 and I'll be done, okay? Okay, take a look at 10. Of the crazy notes I gave you, which one does it look like it is? Number 10. Is it going to be a leg or an altitude theorem?
leg.
It's got to be a leg, right? That's a leg, isn't it? So it's leg squared, right? I know it's say leg squared. So I'm going to have 6 squared equals the piece attached, the hypotenuse attached, times the entire hypotenuse, right? I think that's what we have, right? So I did this right here. We did the leg squared, scoot over. I did the leg squared, 6 squared equals hypotenuse 2, which is the part of the hypotenuse attached, times the entire hypotenuse. So this is easy. That's just 36 equals 12x. Divide by 12, x is 3, okay? And 11, finally, I'm going to do 11, and then we'll talk about the homework, okay? So, are you going to use, this one you're going to either use the altitude or the leg one. Which one do you think you should use? Look at your notes. It's got to be the altitude, right? So this one fits with the altitude nicely. So I'm going to do the altitude. So I'm going to go altitude squared equals hypotenuse piece times the other hypotenuse piece, which is 18 times 8. I don't know. 18 times 8. I got 144. Square root x equals 12. Okay? All right. Now, the homework is going to be out of your journal, and I'll help you with it, okay? So the homework is going to be page 294, 1 through 8, all. And it's your lucky day if you want to get the homework done. We'll do it together, okay?